Hi S3, it's Mr. Bull here again. We're going to be talking through projectiles and the worked examples. If you have not watched the first video that explains the theory behind all the projectiles, go back, watch that, and then click on this one. So let's get started with question 1. So for question 1, it says a flare is fired horizontally out to sea from a cliff top. The speed of the flare is 40 meters per second. The flare takes 3 seconds to reach the sea. And then question 1 says, what is the horizontal speed after 3 seconds? Now, if you remember, we looked back with horizontal motion, we said that it is constant velocity. So this says that the speed of the flare is 40 meters per second, which therefore means that no matter where you are in the trajectory, horizontal speed is going to equal just 40 meters per second. As easy as that. That's an easy question that we can all get marks in every single time. Right. Number 2 says calculate its vertical speed after 3 seconds. Now remember the equation we talked about when we said vertical, which was, remember I said it's not in the equation booklet in this format, it's in the formula A equals V minus U over T. But I said that there's one that we should be remembering, and that is V equals U plus AT. And I also showed you that 2 of these we already know, no matter what U, or the initial velocity, will always be 0. Especially if you're on top of a cliff, your vertical speed is not going to be anything at the top, so it's going to be 0 plus 9.8, and the time here was 3 seconds. So times that by 3. Okay, now you could also do this as well, and you could say, what do we have? We have t equals 3 seconds, you have a equals 9.8 meters per second squared, you don't know your v, and you know that 0 meters per second, so you could start off with that, and that might help you, but I know that these things are all correct, so 9.8 times 3 is 29.4 meters per second. Wonderful. Good, that's number 2 done. Let's try number 3. So number 3 says, calculate the horizontal distance travelled after 3 seconds. So horizontal distance means that we need to use the horizontal speed. So therefore, I'm just going to do what I did last time. I'm going to do V dt because I know it's horizontal. I know it's not vertical, it's asked for horizontal. So my horizontal speed was 40 meters per second, that's what it said, so I've already got that. Distance, we don't know, so put a wee question mark, and the time's still 3 seconds. So all I need to do is a simple equation, distance equals speed times time. Just in case you forget, remember we could do our triangle, and we know that d is at the top, v and t, and I'd cover up the d, and be v times t, and that's 40 times 3, which gives me 120 meters. Okay? Good, that's 3 done. Alright, 120 meters horizontal distance. Now, what's 4 asking me? 4, and then we talked about this very late in the last video about drawing a graph to find out the vertical distance, but this is just saying draw a graph of vertical speed against time. So to draw a graph, we're doing a VT graph, velocity against time. It's just a sketch, we don't need to be accurate. I'm just going to do my 2 axes. That's going to be V, and I'm going to put meters per second, always put units on these axes, and T, which is seconds, and starting at 0. Now, I know the time is 3 seconds, because in both of these they've been 3 seconds, so I know that the x-axis has 3 somewhere, okay? But I also know that at some point, when it reaches 3 seconds, the vertical speed, remember looking at vertical speed against time, was 29.4. So if I said 29.4 and 3, I have a straight line that goes all the way up to here. I could even show you that that goes down to 3, and that goes along to 29.4. Which makes sense, because if you've got a falling object, falling vertically, then it's going to get faster the longer it falls. Okay? So that's really important. That actually explains it well, and it makes sense when we look at it. So that would be my full velocity time graph. And the last one is going to use that, because remember we said that to find the height of the cliff top, we're going to need to use the area under this graph. So distance equals area under graph. Now this is stuff we all used before. We've done this. In fact, our IC exam had a question on this. So area under the graph, it's just a wee triangle, isn't it? This is it here. I guess we could just shade this in a little bit. So it's just that triangle, so it's a half base times height, or length times breadth, however you like to do it. So a half, the base is 3, and the height is 29.4. So definitely using a calculator for this one. So half of 3 is 1.5, so 1.5 times 29.4 equals 44.1 meters, which is the height of the cliff. Right, okay, I think that's everything. So remember, key things, horizontal speed is the same no matter what. Vertical speed, we use this equation here, that is v equals u plus at, the same equation as a equals v minus u over t. Then we also have distance equals speed times time for horizontal. If you want to find out the vertical distance or displacement, you use this VT graph, and then you find the area under that graph to get the vertical distance. And I hope that all makes sense. Any questions, comment, and we can chat about it. And if people are finding something too difficult, I can make another video. But guys, hopefully this helps you out with the rest of the questions and it gets you started. And if not, rewind it, see if you can figure out what I was doing a second time round. Thanks, S3.